Okay, let's unpack this. Picture this. You're scanning the cosmic radio waves, maybe hoping for a faint whisper from across the galaxy, and instead, wham! You get blasted by these incredibly bright, repeating signals.
Yeah, not little green men calling home, sadly.
Yeah.
But definitely something equally baffling to the scientists who found it.
And it's not just any signal, right? We know pulsars tick fast. Fast radio bursts are like quick flashes.
Yeah.
This is different.
Very different. It's a burst of radio waves, okay?
Yeah.
But it lasts about 2 whole minutes, and then it repeats with this almost spooky precision every 44 minutes.
44 minutes on the dot. Every single time. It's like the universe set a timer or something.
Exactly.
So today we're doing a deep dive into this mysterious new object. It got some buzz recently based on findings in a major journal. CNN picked it up too. The official name is ASKAP J1832
Bit of a mouthful.
Yeah. But our mission here is to really dig into what astronomers have actually found about this thing and why it's causing such a stir, why it's challenging our ideas.
And it's fascinating because this discovery, it adds this completely new layer to a whole class of objects scientists only recently started identifying. Long-period radio transients.
LPTs.
LPTs, right? Objects that flash bright radio waves, but on longer timescales, like minutes to hours.
Yeah.
And this ASKAP J1832 thing definitely fits that bill with its 44-minute cycle.
It does.
Yeah.
But there's a twist, a really big one.
Okay.
Alongside those super bright radio flashes, they also picked up powerful X-rays coming from the same spot.
X-rays. From an LPT, I thought those were mostly radio phenomena.
That's what we thought. This is the first time we've seen strong X-rays linked to something that looks like an LPT. It's a game changer.
Why? What do the X-rays tell us? Why is that such a big deal?
Well, X-rays usually mean extreme energy, extreme heat. Think incredibly powerful magnetic fields or maybe matter getting absolutely shredded by intense gravity, something dramatic.
So finding powerful X-rays suggests whatever is going on with this object is way more energetic than we maybe thought LPTs could be. It hints at possibly different physics involved.
Wow. So bright radio flashes and X-rays every 44 minutes. An LPT, but sort of an LPT plus.
Yeah.
How many of these LPTs did we even know about before this one?
The source mentioned fewer than a dozen. It's a really new area, still mapping it out.
Fewer than a dozen.
Yeah.
Okay. And where is this particular one? ASKAP J1832 something.
Or 9/11, yeah. It's actually pretty close, cosmically speaking, about 15,000 light years away. So it's right here in our own Milky Way galaxy.
15,000 light years. Close enough to study, but far enough to be mysterious. It makes it even weirder that it's in our galactic backyard doing something unexpected.
Right.
Okay, so scientists see this weird signal. What were the first thoughts? What could it be? What were they kicking around?
Well, the usual suspects for bright, repeating signals tend to be, compact, dense objects, things left over after stars die.
Like neutron stars.
Exactly. So the initial ideas for this ASKAP object centered on 2 main possibilities. Maybe a magnetar that's a neutron star with a ridiculously powerful magnetic field.
Right.
Or maybe a binary system, like a pair of stars, where one is a highly magnetized white dwarf, another type of dead star orbiting something else.
Those sound like plausible candidates for powerful signals.
Mm-hmm.
But the sources say neither quite fits the bill here. Why not?
And that's the puzzle. That's the real enigma. It's the specific combination of everything they observed, the fact you have both bright radio and X-rays happening together,
Okay.
how they vary, and especially that really long, really precise 44-minute period. None of the standard models for magnetars or these magnetized white dwarf pairs can really fully explain all of those features at the same time.
It just doesn't tick all the boxes.
Not even close, it seems.
And this is where it gets really interesting. There are some quotes in the source material from Dr. Wang, the lead author. Pretty striking stuff. He says, "This object is unlike anything we have seen before."
Yeah, that's a strong statement from a lead researcher.
But then he follows up with, "Even those theories, magnetars, white dwarfs, do not fully explain what we are observing."
That's the core of it. It's not just, a new flavor of magnetar. This is behaving in a way our current physics struggles with.
And he even speculates further, right?
Yeah.
Something about new physics.
He does. He says, and this is a big statement, this discovery could indicate a new type of physics or new models of stellar evolution.
Wow. Okay, hold on. New type of physics. That's huge. That's not just filling a gap. That's suggesting maybe our fundamental understanding of how these dense stars work, how they evolve, might be incomplete.
It's definitely pointing towards something needing a major revision, perhaps.
The source also mentioned comparing this to another LPT they found back in March 2024. How they compare? Are they similar?
Ah, right. That March discovery was also really interesting. They managed to trace that one to a white dwarf that was orbiting really closely around a small, cool red dwarf star.
Okay, a binary system.
Yeah, and the thinking there was that the magnetic fields of the two stars were interacting, kind of tangling up and releasing energy as these long radio bursts.
Makes sense. But what's the big difference compared to our object, ASKAP J1832?
The key difference is light. That March object, the white dwarf or dwarf pair, also showed signals in visible light and infrared light. You could actually see something flickering there.
Right.
Dr. Wang's team specifically looked for that with ASKAP J18320901 and found nothing. No visible light, no infrared counterpart, just the radio and the X-rays.
So the lack of other light signals suggests what? It's a different beast entirely.
It strongly suggests that, yeah. Even though we might lump them both under the LPT category for now because of the long radio bursts, they're likely fundamentally different kinds of systems or objects producing those signals.
So LPT might just be a bucket for various weird, slow-flashing things, not one single type of object.
It's starting to look that way. And another expert quoted Charlie Kilpatrick. He wasn't part of this specific study. He sort of echoes this idea that it challenges our neat categories.
What did he say?
He found it really exciting. He said, this object seems to, quote, bridge the gap between the most extreme magnetars and white dwarfs. He thinks it shows just how extreme these compact objects can be, really pushing the known limits.
Bridging the gap? Or maybe falling into a gap we didn't know existed.
Could be. It's sitting right on the edge, or maybe beyond what our current definitions cover.
Okay, so if it's this unique, this hard to explain, how on earth did they even find it? It feels like searching for, I don't know, one specific firefly blinking oddly in a giant forest.
Huh. Yeah, it was definitely a mix of systematic searching and just incredible sheer luck. Several telescopes were involved.
Which ones?
The first detection came from ASKAP, the Australian Square Kilometre Array Pathfinder. That's a radio telescope array, and it's fantastic for doing these wide field surveys. It scans huge chunks of the sky.
So ASKAP was just scanning, doing its thing, and saw something.
Pretty much. Back in December 2023, it picked up a bright blip. Then, fast forward to February 2024, this object went into this phase where it started pumping out incredibly powerful radio pulses.
How powerful?
Like, ridiculously bright. The source says fewer than 30 known objects in the entire sky reach that kind of intensity in radio waves.
Whoa. Okay, fewer than 30. That's elite level brightness.
And this is where the luck comes in.
This is where the serendipity hits. Pure, unbelievable timing. While ASKAP was seeing these monster radio bursts, NASA's Chandra X-ray Observatory.
The X-ray telescope.
Yeah, Chandra has a much narrower field of view, right? It focuses on small patches. By complete coincidence, it happened to be pointed at something else nearby, but its observation window just happened to overlap with this object's location.
No way.
Exactly when it was having this super bright radio outburst.
So Chandra just happened to be looking in the right direction at the exact moment this thing flared up in radio and was presumably emitting X-rays. Bingo! Talk about luck. Dr. Wang actually said it felt like finding a needle in a haystack. ASKAP's wide view found the haystack, you could say. But Chandra's narrow X-ray vision just stumbled across the needle when it flashed.
That's amazing. What a coincidence.
It really is. And just to be sure, the X-rays weren't, always there. Chandra looked again 6 months later, August 2024.
Yeah.
Nothing. No X-rays detected that time, which confirms the X-ray emission is transient. It comes and goes, probably linked to those bright radio phases.
Okay, so ASKAP found it. Chandra got lucky with the X-rays.
Yeah.
The source also mentioned another instrument, CRA-CO.
Yeah, CRA-CO, the Coherent Radio Astronomy Core. That's a newer piece of kit designed specifically to catch very fast, fleeting radio signals, like those fast radio bursts.
What does CRA-CO do here?
They used CRA-CO to get really fine-grained data on the radio pulses themselves, confirming how they repeated, nailing down that 44-minute period precisely.
It really sounds like a team effort, not just instruments, but people coordinating.
Oh, absolutely. It was a global thing. The data involved telescopes and researchers in the US, South Africa, India. These big discoveries often rely on that kind of international collaboration now.
Okay, just to clarify for listeners, how is this different from a regular pulsar? They also pulse, right?
Good question. Pulsars are also spinning neutron stars, but they pulse incredibly fast, usually milliseconds to maybe a few seconds between pulses. This object signal repeats every 44 minutes, and the pulse itself lasts for 2 minutes, so vastly different timescales.
Got it. Slower, longer, weirder. Okay, so we have this incredibly bright, slow repeating object shooting out radio and X-rays, defying our models found by luck. What now? What are the next steps to figure this thing out?
More observations, definitely. The main focus will be getting more time with sensitive X-ray telescopes like Chandra.
What would more X-ray data tell us?
It could reveal details about the temperature of the source, maybe how the X-rays are actually being generated, possibly help constrain its size or mass. Those details are crucial for figuring out what it is. Is it a super weird magnetar? Something else entirely?
And just finding this one is already making scientists rethink the whole LPT category.
Fundamentally, yes. Before this, LPTs were already puzzling, but finding one with powerful transient X-rays suggests the population might be much more diverse, much more energetic than we realized.
So there could be more like this out there.
That's the hope and the expectation. Dr. Nanda Raya, another author on the study, basically said finding even one hints that there could be many more waiting to be discovered. And she stressed that the transient X-ray part opens fresh insights into their mysterious nature. Dr. Wang and the team are definitely going to keep looking.
So let's bring this back home for everyone listening. Why should you care about this object? ASKAP J1832, whatever, 15,000 light years away. If it sounds abstract, maybe.
But it's not, really.
Exactly. Because this thing, right here in our own galactic neighborhood, it's actively pushing back against what we thought we knew about some really fundamental stuff. How stars live and die, how gravity and magnetism work in extreme conditions. It might even be hinting, as Dr. Wang said, at physics we haven't even conceived of yet.
It's a really potent reminder that the universe is still full of surprises. We haven't figured it all out. Not by a long shot. Our textbooks aren't finished chapters.
New discoveries can just pop up and force us to rethink everything. It's kind of exciting, actually.
It's why we do this.
So, wrapping up our deep dive on ASKAP J18320911, we've got these unique repeating radio and X-ray signals. We've got a major challenge to our understanding of magnetars, white dwarfs, LPTs, maybe all of the above.
And a fascinating story of discovery, part deliberate search, part cosmic coincidence.
It definitely leaves you wondering.
For sure.
So here's a final thought for you to mull over. Since this one object is baffling scientists, hinting at new physics or new types of stars, and suggesting there could be many more LPTs out there, just consider this. If this one object relatively nearby can throw such a wrench in our understanding, what other completely unknown, maybe even weirder cosmic objects are still hiding out there in the dark, just waiting for us to stumble upon them and rewrite our textbooks all over again? What part of this cosmic enigma stands out most for you?